So the next step after fitting the model into the data, we'll also need to start evaluating that each of these models scores. So call this like evaluate the models and store or append its scores to a variable that we created, which is here, it's called model scores. Model scores. To do that, just gonna call model scores and we'll open like the array that we keep it as, we'll call it as name, which is the model in our case, model name. Close that, and then we'll equal that to model.scores, including the X test and Y test. Test and Y test. Now let's have all of these returned into the model score. Return model scores. So we have the functions that we have used here. Function is used and score. In our case is this one. So this function is designed to fit each model on the training data and evaluate the model on the testing data. The function takes the following parameters, including the models that we created, which is the dictionary containing the machine learning models, the one we selected, the 3 models. Also, it contains the, as you could see here, so it takes the models we created here, and we already defined it. So this function takes the models and the features we have, which is the X-train, the features which we call them the independent variable for the training set. And then we have the X-tests. The X-text present the features, the independent variable for the test set, okay? And then we have the Y-train. The Y-train, it's the target labels or the dependent variable that we are trying to predict for the training set. And then we have the Y-test, the last set, which is the target labels for the dependent variable for the test set. And then we choose the function to loop through each model in the model dictionary here, as you could see here. So it trains each model using the fit method that we created on X-train and Y-train, and then evaluate each model using the model scores. Here you have it. To evaluate it based on the X test and Y test, which is by default computes accuracy for classification problem. The function returns a dictionary of model names and their corresponding accuracy scores on the test set. So our data will be model fit on the training data, and then we'll test its ability with accuracy percentage to detect the pattern on this test set, okay? that we have mainly. So okay, the random seed, as you set it to 42, which is, you know, ensure the reproducibility of the results, especially for models like random forest that involve randomness and their learning process. And the model evaluation that we have here, so the score method here, it's used to evaluate the model-based accuracy depending on the type of classification problem and other metrics like precision. Also, it provide the recall. F1 score might be like informative to evaluate our model. So that's all for explaining the code. I'll put more comments so you can, you know, go through it. You can understand more about how you create model dictionary and how you set the function to fit and score models. That's all for this set. So now after that we have created the main functions that gonna fit and score the models. Let's create how we can call the model evaluation to start fitting and evaluating and returning back the scores that we are aiming to see for the three main models. So to start with that, we'll call this as the function that we created, which is the model scores, and that's gonna equal to fit, which is the function that we created above, fit and score. Okay, and here we'll choose the models, the three models that we created, which is equal to models. And then we'll have to add the data that we are aiming to use, including the X train. Equal to X train dataset. Also, we have the same thing for the X test. It's equal to X test. Next, we have the Y train. It's equal to Y train dataset. The last one we have here is the Y test, which is again equal to Y test dataset. Now we can call the model score function. Let's run both of the codes. So let me run this one. As you could see that I have added some comments for you so you can reference these or recall them in case if you have any confusion. These are the data sets that we're gonna use. These are the models that we created. They are the main ones: logistic regression, KNN, and random forest. It is the function to fit and score, including the data that we are gonna use. So the model score, which is, this is how it's gonna evaluate our model. Let's now call this function and see what would be the output. Okay, as you could see, the first model, which is using the logistic regression, it has returned 0.885. which is good for as a starting point. And then we have the k-neighbors classifier. We have 0.68 as start point, and the last model that was evaluated, the random forest. So think as each of these data sets, including the X-train and Y-train and the X-test and Y-test, it was fitted to each of these models to evaluate which one has the higher accuracy when evaluating the data that we have to predict the heart disease problem. So as we say, the KNN has 0.68 and the random forest has 0.83. So we can say the most as a baseline. It's not the final decision here, but as we could see that the logistic regression and the random forest models has scored the highest two, and we have the KNN is in the last place here. So the output will depend on the results of fitting and evaluating the models on our data set. So as I mentioned that these numbers or percentages, we call them, these are the accuracy scores for each model. The dictionary will look like something like, assuming the model will be trained and evaluated on the provided training and testing sets. I do understand it might be hard to read, so let's try now to visualize and compare the performance of each of these models, but let's do it in more visual way so it can be easier to understand. So here we have, I think, okay. So what was the, okay, it's a model score, not scores. Let's call that as model score. So let's save it on that way. Have the same results. So now I think we are good to run this code. Okay, great. So here we have the main three models that we selected with their, visualized accuracy. So as you can see, we have the logistic regression above 80%, also the random forest. However, the KNN seems the lowest accuracy had. So we can consider this as a baseline. So your baseline model is just a starting point. Like we haven't done any cross-validation, we haven't done any feature selection or hyper parameter tuning. Like you can consider this as the baseline scores of your model. So from there you can, start doing incorporating techniques like cross-validation or hyperparameter tuning, feature engineering, or using like ensemble methods and error analysis. So we can improve the model performance and make more, informed decision on the next step. So we have the first set prediction from the model. While it's useful, to set a baseline. May it not be always the best representation of the model potential, since we haven't done any improvement on these models. But it's very important to recognize these several steps can be taken further for after the training and initial model to improve the performance and optimize its results. So next, let's look how can we improve each of these models using different techniques, including the hyperparameter tuning or feature selection. So let's do that now.